the midnight glow. I hate to do it, but I did it though. I'm gonna bite into the body like the risk is no. I got a souped up car and what's it called? Sipping on the boom bap that I'm illogical. I ride the fader and I ride it low. I'm gonna slip into the field like Han Solo and electrified zoo into the amplifier. 1, 2 into the amplifier. When you got to get 2 into the amplifier. 1, 2 into the amplifier. I'm rolling.
All right. Hi guys, welcome back. Thank you very much for joining us tonight. Let's see. Looks like we've got Eagle 1J who went pro. Thank you very much. X-Ray Charlie, Costed, Hildrick, Yakin Kehoe, John Hubbard, Powers USA, the Midnight Manufacturing Company, Yulman, and we've got a couple lurkers out there. Thank you very much, guys, for coming out and actually supporting us. So, got a few things happening here today. Let's go ahead and cut that off here just for a second. So, we got got Carl here, obviously, and also Daniel Gifford in the back. So, say hello. Very good. All right. And got a lot of things to go over tonight, guys. So I apologize for the late notice, but we were still working away, getting everything ready for tonight. So
we're always working away.
Very, very true. So I'm going to go ahead and move the camera over just a little bit. Let's see. I know you guys are going to be asking me probably immediately about the status of the surveys. The surveys have not been sent out. That's my fault. I apologize for that, guys. We've been working out some of the details when it comes to the pricing, and I wasn't comfortable enough and didn't have enough information to send it out. So I apologize if you guys have been waiting on that. That's on me. So
not entirely. Blame the old man a little bit. We're all good.
So all right, guys. Wow.
Ready to start?
I think we're ready to start, guys.
You want me to slide up there, or you want to?
Yeah. Absolutely.
That camera's right in the field of view, isn't it?
Yes, it is.
It's like you're looking at your one-eyed cyclops. So tonight we're going to cover a couple of different bases. It's been a really good week for us. I don't want to cast any doubt on that. So we're going to cover on a couple of different things. First, we're going to cover on some improvements we made to the EMO 25. We'll talk about the ABS head and show you what we've evolved for that. Touch overlays for the engines. Can you say 3D scanning? Yes, we'll have a little bit of a demo tonight. And I think that we're pretty well framed up. It's not Hutch's fault that we didn't send out survey. It's really that I wasn't able to give him the complete details of what it is we're trying to present to you. We're trying to make it as simple as possible. So it's A, B, or C. And you don't have to do anything. You just say, okay, surprise me and send me what you think I bought or got. Backed. Backed is the right word in this case. And we'll just do our best to do that. One other thing is, as we have mentioned in the past, we have envisioned numerous new uses for this system, this manufacturing system. And I think that I'm a little frustrated in that I ordered the things to give you a really amazing demo tonight, but we'll still show you one of the things we tested and give you a really amazing demo on the next broadcast. Has nothing to do with printing, has everything to do with what do you do once you've printed it? How do you send it to your grandma? And you'll see what I'm shortly. And I think you'll find there are a lot of uses, and I'm hoping that Ken in Canada especially gets to see this broadcast, because I know he already has 10 ways to use what I'm about to show you guys.
He is on tonight.
Sweet. So, well, shalom booga booga, because Ken has given me more good ideas. He's the one responsible for sending Repetier our direction, which in the beginning I was really mad at, but it turns out it put us a long way ahead, and I've been able to get a lot further along because of it. So thank you, thank you, thank you. Okay, let's start on the first part. Let's talk about the Emo 25, because that's the easiest thing, and what we did this week with it. Well, lo and behold, there was a couple details. We have a backer. You guys all met him, Tim. He's from Australia. And Tim wrote me like an encyclopedia review of our Emo 25. And although it had some 40 grit sandpaper in the verbiage, it was pretty much on the money as far as some observations he made, with a couple of differences of opinion. Still, a lot has been taken from what he said to us. Most of it we'd already recognized as improvements that we'd want to make before we released it in the wild. And what comes to finality is it's time for us to go ahead and push those out into the wild, because a lot of you guys have already asked, hey, we want one with our printers, and so we got to get them through the process line. So if you'll hang on a second, I'll show you the most recent, and I'm actually going to bring two up. So just hold on a second.
While he's doing that, for you guys who have emailed me about getting an Emo 25, yes, we will be giving you guys, specifically the Kickstarter backers, a pricing on that very, very soon. So for those people who have requested it, don't worry, it's coming. I'm sorry, I've just we're just in the middle of putting all this stuff together and dialing it in. So that's the reason why we had to wait for a moment. So.
We had to wait because I wasn't sure where Sable had put it. All right, so
thanks, Fuel Trick. He says, regarding simple survey, or maybe D, if you consider 2 times B minus 1 times C isn't enough for you.
Yes, that would be tough. Well, is Shieldrick the guy in Austria? I always think he is. I know he was always getting up.
Yes. So
I'm coming to see you, I promise, and I'm bringing your printer to you personally. And it's going to be like this one, because we were doing our review and you bought a super system, and this is now the super system. So yeah. Okay, let's go through this. So the old, and we still have to dress up the wires a little bit. This is the Volcano, and the Volcano is the heated Emo 25. So the idea here is that we now have put the flex cable in. You'll like that. So now it has a high reliability. You can go through 100,000 cycles. That means 100,000 extrude cycles, and you don't have to worry about the wires breaking or anything. The other thing is that this one, which I have locked in place because we were demonstrating some wax to somebody, has a insulating layer in it. So you can probably see it. So the peak insulates it. The block can go to 100 degrees C. We've already tested it. Works great. And it mounts in a standard mounting system. Works with a standard software. And it registers just like any other guy. And it plugs right in your standard process. It even uses the standard not heater cartridges, but the emulsion cartridges. So if you get a regular Emo 25, which is just a room temperature extruder, and you also get a Volcano, you can mix and match your cartridges all you want. We already checked the rubber seals are good to 100 C. We have no plans at this time to make a 500 degree C Volcano, so those of you who are thinking plasma magnetic rotational device, not going to happen in 2013. Okay, so, but we just wanted you to see that. A couple of the key features was we moved the motor from the back to the front, and we did that so that now it fits in our system 23 as well. You have to leave the top off because this guy sticks up a long way, but you can run it in system 23. So there's no compelling reason for someone to go out and spend their hard-earned money on a bigger system if they don't want it. All right. So just to be clear, so that's the first thing on the Emo 25. So let's talk about the second thing. We got a visitor this week. Mr. Hutchison here was smart enough to see that somebody, yes, somebody was doing a special Kickstarter where they were making videos, instructional videos on how to work precious metal clay. And it turns out this person was only 6 or 7 miles from us.
Yes.
And so he reached out, he actually backed her, and then he reached out to her and said, hey, we see that you're doing precious metal clay, and you're a world-class expert. You are what we call a subject matter expert on precious metal clay, and we think we can print it. If that's interesting, contact us. She wrote back, oh, I'm so busy, this Kickstarter is amazing, no chance I can see you, I want to see you, but no chance I can see you until like maybe 2014. Next day she says, maybe I can see you in November. Next day she says, I'm coming over to see you tomorrow morning.
Yep.
So Thursday she showed up and she says, okay, I don't have time to do anything. I'm just going to show you something real quick and then I'm out of here. I got to go make my videos. Okay, so she posed the first thing and I said, you open the package, I hear it dries out. You want me to put some in a tube and print for you?
Now, she did show us quite a few of her prints.
She showed us tons of stuff.
Not prints, but things that she's created.
Yeah.
Just gorgeous.
Don't let me slight this over. She is awesome, and we are blessed to have her spend any time, even the 45 minutes that she stayed or so with us, was a wealth of knowledge. She moves everybody forward, and she showed us something she made that I think we could actually print. And so, I mean, because a lot of stuff you can't print. Come on, let's be honest. Some things have textures to them that are not going to be print feature size friendly.
Because they're...
So, that said, she was quite good. We grabbed and made up a little extruding material, and lo and behold, it printed. Voila, fantastique. So good, she actually called the guy up who makes the precious metal clay, who she has a good relationship with, and she says, you gotta talk to these guys. This is amazing how beautiful it comes out, how smooth and even. Okay, I'm not embellishing much here. Truth is, she was very much enthusiastic, and we're happy to say that precious metal clay is something that at least copper, we have verified and witnessed and done ourselves. We're not printing it tonight because we're supposed to receive a couple of kilograms of it in the next week or two, and then we will do an official copper print, and we will actually post-process it and show off the post-processing with pictures a day or two later. It shrinks 10 to 15%, which means for anybody who's trying to do precision work, probably not going to, you're not going to probably print a gear, but for a artistic standpoint, I can see it having some real uses. So there.
Yes, Eagle and Jay has put up here for you guys who are going to be watching this video afterwards. It was Pan East, yes. She's a very, very big person when it comes to precious metal clay, and more specifically enameling with precious metal clay. And I only found out about her roughly about, I'd say this, 2 to 3 hours before her campaign ended. So I couldn't email out everyone to let everybody know to go back her. But he did leave the Eagle and Jay did find the correct link, so it's in there in the chat room. But if you are on Kickstarter.com and you want to see who it was, it's Pan East. Just sounds and looks just like it sounds. So Pan East. Enameling on metal clay videos. So, yes. It does shrink consistently. Actually, I can't say it shrinks consistently, but it does shrink. Some versions shrink between, I think she said 8 to 9%, and others shrink 15 to 20% or something like that.
Yeah, the shrinkage is outside of engineering standards normally, so I would consider it more of an artistic thing, or a blank. You could create blanks and then go through a secondary grinding process to get some real precision out of it. If you were thinking of fabricating something out of a metal that you could actually use. And it really is metal. Yeah. The other thing is she did bring to the plate lots of knowledge. And she told us that for a support material, we could print with what's a wood clay they have?
There's a wood clay, and then there's a cork clay.
That's it, yes. And that both of those would be very interesting. And yes, we could. Someone mentioned X-Ray Charlie. That's Ken, I'm pretty sure. He mentioned that you could oversize it and then let it shrink down to size. Conceptually, you're correct, but I have no experience with the distortion model, cross-section, air, hydration, all that good stuff. So I'm going to leave it for an expert like you to figure out how to make that sucker stretch, and then get it the size you want.
And we'll also ask Pam as well when she comes back.
I'm getting old, and everything's a blur. I cannot remember if we told them what we did with that last week or not. I know I destroyed the print, but
We talked a little bit about that, but we did not. Like we printed it off for Sergio when Sergio came by, and also Vincent.
so I haven't told him that we printed a hot.
I'm not sure if
Maybe you guys can tell us. Did we mention last week that we printed at 50 degrees C in the volcano at 15 thousandths layers, which is oh.
We did not.
Well,
I'm sorry.
Maybe I can make this little sidestep. It's a blur. We're getting something hitting us every 4 or 5 hours. This reminds me of a trip to Alaska I took once with my great son here. I'd say that was the best trip we ever took.
I agree.
There you go. So if you get a chance to go to Alaska, take your son, have a great time. But don't feed the bears.
No. Oh, good Lord, no.
And leave the salmon oil somewhere else.
Yeah, be careful with the smells.
Okay, so we got some plasticine from another manufacturer. This stuff was hard. He was breaking a sweat and getting cramps trying to pack the tube. However, we know that plasticine gets soft when it gets warm. So we heated a little bit of it up, make it easier to pack, and got a tube full of it, and we stuck it in here. And I set the temperature to 50 degrees C.
Yep.
I went with a 1 millimeter nozzle, not the 2, but the 1, thinking there's no chance this has any way it's going to print. I also set the layer height to half what we've been working. Before we worked at 0.6 millimeters, I moved it to 0.3, which by the way is 12 thousandths of an inch approximately. Then, I didn't print that boring square igloo thing, but I printed a larger version of a part that was the very first part we showed you, the little white round part with the square cut out in it.
This was the part that was on Kickstarter.
Yeah.
So the one that we showed that we did 100 micron layer thickness.
Yes.
I was about to.
Thought it would have no chance of printing. Not only did it print, it printed phenomenal. The layers were so straight, the detail was very good. And now I'm telling you, but I'm not showing you. That's because I think it got destroyed. And I don't even remember why we destroyed it. So I'll tell you what I'll do. We'll set this up.
I know what we did.
I was trying to show him something anyway. I'll set this up, and we'll do one of those prints on the next broadcast because I think it'll make you think appropriately on what can be done with extrudable types of fabrication. I'm not saying anything else, just leaving it there. But know that the volcano was putting out the juice, and been very happy with its performance so far. It heats up quickly, gets to 50 degrees C in like under a minute.
Yeah.
And so you're ready to print almost instantly. And had no problems with the drive mechanism, no feedback from the temperature or anything. And the isolation was great. The circuit board didn't get hot or any of that stuff. Okay, so now that we talked about that, and we talked about the regular Emo 25, let's move off on that one. And let me go grab the next show and tell item, which I'll be right back.
Ebo and Jay, you asked what that part was anyway, and what he's asking about is if you look on our Kickstarter page, and you can always go to HYREL 3D on Kickstarter, put that in there. Hold on a second, whoops.
I might have it in my drawer somewhere.
When you look at it, where it is, okay, it was basically our test model part, and if you give me 1 second, let me go ahead and put this guy over here, just so that whoever's watching this, you can see it, can see it afterwards. This was our test model part that we did on our Kickstarter, so if we go to the very top, there you go.
Yeah.
It'll be like 10 more minutes for
And that was the part that we actually printed. And as you guys can see, we proved that it was basically 100 microns layer thickness wise.
And if you see the nice striations, we got similarly detailed, of course 3 times that, but similarly detailed walls actually using plasticine. It was beautiful. Which means the plasticine with this type of dispensing is viable as a support material because we can give you the consistency and the definition and the tolerance that you would like to get in some cases. I'm not in all cases, but anytime you got a reusable support material that goes down in wider swaths, i.e. fills up faster, it's always interesting to me. It's not as good as a shaving cream, which we're working on. Okay, is it my turn?
Yes.
Okay.
Yes.
Let's talk about ABS, okay? Several really big steps were taken this week. So, first off is Tide, who has been relentless, got me the 30-watt heater guys.
Thank you, Tide.
Yep. He ordered 200 samples for us. I know it sounds like a lot, but they're not that expensive, and we're 99% sure they're exactly what we wanted. 40 watts is too much. They tend to burn up. 15 watts is not enough because it takes from now until Dracula comes out, i.e. midnight, to get hot, and that's not fast enough for us. I mean, we're talking 15-minute heat up time. So between heating up so fast that it burns itself out periodically and not getting hot enough, we found out that we have a standard cartridge, yes, standard, which means it's being mass produced, 30 watts. 30 watts. It's perfect. It is 2.5 amps. It is the sweet spot of the design. It is exactly what I've been trying to find for 7 months, and we got that this week. They're already at the crimping house with the pins being crimped on them. So he's already received them and put them over to the people that do our crimping for us, and they should be ready tomorrow for shipment. So to me, that's good stuff. It's real good stuff. So that's one thing. But wait, there's more. Our young sorcerer's apprentice, Daniel Delmonico, who's a Georgia Tech student. Actually, he's graduated, and now he's in the master's program. One more year, and he'll be a master mechanical engineer. That's it. And actually, he's doing that school proud. So good job, Daniel. But we went fisticuffs. We were back and forth and upside down and stretching, and we were not happy with the way the pressure bearing was doing the job on any of the designs. The ones we purchased for examples and the ones we designed ourselves. So we looked at each other and we said, we've got to do a better way. We've got to do a better way. The pressure bearing, for those of you who don't know what that is, I'm holding in my hand a hob nut, which I like to call the crunch nut because it crunches the material. And I don't know if I can get that to focus in or not.
Yeah, you have to.
There we go, right there. Okay, there are little teeth that are serrated all the way around that groove, and the material as it flows.
What are you looking for?
Some material. Oh, here. I just happen to have some sitting right here. Oh, he's got some. Now he's showing off.
It's 1.75 millimeter plastic, guys, just for anyone who was asking.
Okay, so as this flows past it, as the bolt turns, you have to have something that puts pressure to squeeze it so that it keeps the friction there. So you see how that's working? And if I could ship my finger inside of every one of these extruders, it might work, but it gets pretty hot. Okay, here's the number one problem I had. These little teeth tend to eat a little bite out of the plastic, and then it has no way of getting more traction. That's not a good thing, because then you got to pull or push to get it started. And I don't know about you, but if my fingers are crossed, I can't pull or push. I don't have any more hands to work with. So we went back and forth, and I said, you know what, the perfect ideal would be to have 2 of these nuts spinning so the material would be pinched between 2 of them so that you had drive from both sides. Of course, there's a flaw in that logic, because if there's 2 of these steel guys and one of them strips off, you're still not going to get any pressure because the material is just going to float between the 2. We thought, man, why can't we get an elastic material? And then it was sitting right on our desk. We have been using special silicone rollers for the last 20 years on another product. And we had a couple of old ones laying around. I said, I'm going to go and put that on the lathe, and I guarantee you're going to get the dreamiest, most fantasticest, that's a good thing, wonderful pressure with friction. And I won't get the exact detail because tomorrow I have a Skype meeting with the guys writing the patents for this. But what we are doing is we're making it so that the drive mechanism, the drive gear, whatever it is, whether it's a hob bolt or the next thing I'm going to show you, it touches against the roller, and I just happen to have a little roller installed here. So on the inside, it literally is touching, so that the roller turns when the hob bolt turns, even if there's no material touching. That's cool because if the hob bolt starts to slip, your silicone roller is deformed anyway because it's pressing through the material, and it's putting forward pressure as well. So you're not just driving from one side, you're driving from a fairly large angle because the silicone deforms around the material and drives it. So
To make a long story medium, in theory, your material comes down and it goes in and out all day long, and it goes in and out with pressure. And I think I'm doing this without my fingers crossed. I think you'll like that.
Yeah.
I think for those of you who were watching my earlier references, I just got tired of feeling like I had to cross my fingers before I could print with plastic, that I wasn't sure whether it was going to jam up or whether it was going to get too much materials peeling off and things like that. So,
Yoder asks, so why not regulate it using a phase angle control? Use 3 of them bending the material to get more friction.
That's a very good question. You probably are better at this than me, and I would be glad to sit down with you and look at that. Every time we bend the material, we have a real problem with it. Number one is you set up stress in the material, and you got to remember, we're pushing this material into a tube because it goes in the extruder, and when it kinks, and it does, it folds back on itself and then creates a plug. So you have to be very careful about whether or not you kink the material. And that's universal. That was one of the first things we found. I think we call that blowback, actually. So that's not desirable. But I'm sure there might be some other ways of doing this. We racked our brains, we found out. Okay, so let me just go on to the next thing. This works, it's awesome, and tomorrow DHL is delivering 10 of the 30 watt. Yes, I know, I said they were already getting crimped. Well, I had them pull 10 pieces out to send us so we could build up immediately. We'll crimp on their own pins for the first 10. So tomorrow at this time, I'm hoping we're printing plastic with the new guys. All right, so to me this is huge. It's a huge week for us because this is one of those problems that's been a pain in the neck. So now I'm going to share another one with you. Now we bought these, and I'm not putting, I'm not sharing any secrets that I wouldn't share with anybody else. Yeah. We bought this from See Me CNC. If anybody needs one, for like your cat needs its tail cleaned or something like that, go online, seemecnc.com. They're $9 a piece, and for lack, I don't know that these won't be what we go with. They're nice enough machining job, and these guys are friendly. We like them, so I have nothing bad to say about them. However, as is often the case, every morning I do a little online research, whether it's on the scanner, some software, or something. And I was particularly perplexed with how you make a hop bolt on Thursday. So I took a little time out and said, who's got this technology? This looks so difficult to do. And, well, it's not as difficult as they say. Actually, some beautiful YouTube videos show you all the secrets and how you can use a lathe and a tap, a couple of bearings on a shaft, and voila, you can hob just about anything. Why is that important? From my side, granularity. This is a big gear. That means that every rotation moves a lot of material.
It does.
It's desirable, but maybe it's more material than is optimum. But I can't go much smaller than this because this is the guy I can buy. The perfect solution, if it has enough traction, would be to